Hi, this is Dr. C coming to you from Dr. C Snippets, where I want to take chunks from different podcasts and bring them to you, wrap them to you in a little package to do two things. One, to expose you to certain concepts in AI that I think are important. And second, to introduce you to some of the personalities that are behind these concepts. So today's concept idea is going to be the scaling hypothesis, which has been driving AI since 2014. And one of the main individuals behind that concept is Dario Amodi. Amodi is the CEO of Anthropic, a company that's brought us Claude, one of my favorite LLMs. Prior to that, he was with OpenAI and Sam Altman. There was some disagreements about the concept of safe AI, and so he left OpenAI, founded his own company. And so we'll hear what he has to say about the scaling hypothesis in the interview with Lex Fridman. The second individual I want to introduce you to is Gary Marcus. Marcus has a PhD in cognitive science and computer science from MIT. He is an individual who is a naysayer about the scaling hypothesis, at least the ultimate potential of the scaling hypothesis. And people are looking at the scaling hypothesis to predict AGI, artificial general intelligence. And so I have a small snippet from his podcast with Alex Kantrowitz. So let's jump in and we'll take a look at the Dario Amodi podcast and what he has to say about the scaling hypothesis.
Let's start with the big idea of scaling laws and the scaling hypothesis. What is it? What is its history, and where do we stand today?
So I can only describe it as it relates to kind of my own experience, but I've been in the AI field for about 10 years. And it was something I noticed very early on. So I first joined the AI world when I was working at Baidu with Andrew Ng in late 2014, which is almost exactly 10 years ago now. And the first thing we worked on was speech recognition systems. And in those days, I think deep learning was a new thing. It had made lots of progress, but everyone was always saying, we don't have the algorithms we need to succeed. You know, we're only matching a tiny fraction. There's so much we need to kind of discover algorithmically. We haven't found the picture of how to match the human brain. And when, in some ways it was fortunate, I was kind of, you can have almost beginner's luck, right? I was like a newcomer to the field. And, I looked at the neural net that we were using for speech, the recurrent neural networks, and I said, I don't know, what if you make them bigger and give them more layers? And what if you scale up the data along with this, right? I just saw these as like independent dials that you could turn. And I noticed that the model started to do better and better as you gave them more data, as you made the models larger, as you trained them for longer. And I didn't measure things precisely in those days, but along with colleagues, we very much got the informal sense that the more data and the more compute and the more training you put into these models, the better they perform. And so initially my thinking was, hey, maybe that is just true for speech recognition systems, right? Maybe that's just one particular quirk, one particular area. I think it wasn't until 2017 when I first saw the results from GPT-1 that it clicked for me that language is probably the area in which we can do this. We can get trillions of words of language data. We can train on them. And the models we were trained in those days were tiny. You could train them on 1 to 8 GPUs, whereas, now we train jobs on tens of thousands, soon going to hundreds of thousands of GPUs. And so when I saw those two things together, and there were a few people like Ilya Sutskever who you've interviewed who had somewhat similar views, right? He might have been the first one, although I think a few people came to similar views around the same time, right? There was, Rich Sutton's Bitter Lesson. There was Goran wrote about the scaling hypothesis. But I think somewhere between 2014 and 2017 was when it really clicked for me, when I really got conviction that, hey, we're going to be able to do these incredibly wide cognitive tasks if we just scale up the models. And at every stage of scaling, there are always arguments. And, when I first heard them, honestly, I thought, probably I'm the one who's wrong. And, all these experts in the field are right. They know the situation better than I do, right? There's, the Chomsky argument about like, you can get syntactics, but you can't get semantics. There was this idea, you can make a sentence make sense, but you can't make a paragraph make sense. The latest one we have today is, we're going to run out of data, or the data isn't high quality enough, or models can't reason. And every time we manage to either find a way around, or scaling just is the way around. Sometimes it's one, sometimes it's the other. And so I'm now at this point, I still think, it's always quite uncertain. We have nothing but inductive inference to tell us that the next few years are going to be like the last 10 years. But I've seen the movie enough times. I've seen the story happen for enough times to really believe that probably the scaling is going to continue, and that there's some magic to it that we haven't really explained on a theoretical basis yet.
And of course, the scaling here is bigger networks, bigger data, bigger compute.
Yes.
All of those.
In particular, linear scaling up of bigger networks, bigger training times, and more data. So all of these things, almost like a chemical reaction. You have 3 ingredients in the chemical reaction, and you need to linearly scale up the 3 ingredients. If you scale up one, not the others, you run out of the other reagents, and the reaction stops. But if you scale up everything in series, then the reaction can proceed.
And of course, now that you have this kind of empirical science / art, you can apply it to other more nuanced things, like scaling laws applied to interpretability, or scaling laws applied to post-training, or just seeing how does this thing scale. But the big scaling law, I guess the underlying scaling hypothesis, has to do with big networks, big data leads to intelligence.
Yeah, we've documented scaling laws in lots of domains other than language, right? So initially, the paper we did that first showed it was in early 2020, where we first showed it for language. There was then some work late in 2020 where we showed the same thing for other modalities, like images, video, text to image, image to text, math, that they all had the same pattern. And you're right. Now, there are other stages like post-training, or there are new types of reasoning models. And in all of those cases that we've measured, we see similar types of scaling laws.
A bit of a philosophical question, but what's your intuition about why bigger is better in terms of network size and data size? Why does it lead to more intelligent models?
So in my previous career as a biophysicist, so I did physics undergrad and then biophysics in grad school. So I think back to what I know as a physicist, which is actually much less than what some of my colleagues at Anthropic have in terms of expertise in physics. There's this concept called the 1/f noise and 1/x distributions, where often just like if you add up a bunch of natural processes, you get a Gaussian. If you add up a bunch of kind of differently distributed natural processes, if you take a probe and hook it up to a resistor, the distribution of the thermal noise in the resistor goes as 1 over the frequency. It's some kind of natural convergent distribution, and I think what it amounts to is that if you look at a lot of things that are produced by some natural process that has a lot of different scales, right? Not a Gaussian, which is kind of narrowly distributed, but if I look at kind of like large and small fluctuations that lead to electrical noise, they have this decaying 1/x distribution. And so now I think of like patterns in the physical world, right? Or in language. If I think about the patterns in language, there are some really simple patterns. Some words are much more common than others, like the. Then there's basic noun-verb structure. Then there's the fact that, nouns and verbs have to agree. They have to coordinate. And there's the higher level sentence structure. Then there's the thematic structure of paragraphs. And so the fact that there's this regressing structure, you can imagine that as you make the networks larger, first they capture the really simple correlations, the really simple patterns, and there's this long tail of other patterns. And if that long tail of other patterns is really smooth, like it is with the 1/f noise in, physical processes like resistors, then you can imagine as you make the network larger, it's kind of capturing more and more of that distribution. And so that smoothness gets reflected in how well the models are at predicting and how well they perform. Language is an evolved process, right? We've developed language. We have common words and less common words. We have common expressions and less common expressions. We have ideas, cliches that are expressed frequently, and we have novel ideas. And that process has developed, has evolved with humans over millions of years. And so the guess, and this is pure speculation, would be that there's some kind of long tail distribution of the distribution of these ideas.
So there's the long tail, but also there's the height of the hierarchy of concepts that you're building up. So the bigger the network, presumably you have a higher capacity to...
Exactly. If you have a small network, you only get the common stuff, right? If I take a tiny neural network, it's very good at understanding that, a sentence has to have, verb, adjective, noun, right? But it's terrible at deciding what those verb, adjective, and noun should be and whether they should make sense. If I make it just a little bigger, it gets good at that. Then suddenly it's good at the sentences, but it's not good at the paragraphs. And so these rarer and more complex patterns get picked up as I add more capacity to the network.
Well, the natural question then is, what's the ceiling of this?
Yeah.
Like, how complicated and complex is the real world? How much stuff is there to learn?
I don't think any of us knows the answer to that question. My strong instinct would be that there's no ceiling below the level of humans, right? We humans are able to understand these various patterns. And so that makes me think that if we continue to, scale up these models to kind of develop new methods for training them and scaling them up, that will at least get to the level that we've gotten to with humans. There's then a question of, how much more is it possible to understand than humans do? How much is it possible to be smarter and more perceptive than humans? I would guess the answer has got to be domain dependent. If I look at an area like biology, and, I wrote this essay, Machines of Loving Grace, it seems to me that humans are struggling to understand the complexity of biology, right? If you go to Stanford or to Harvard or to Berkeley, you have whole departments of, folks trying to study, like the immune system or metabolic pathways. And each person understands only a tiny part of it, specializes, and they're struggling to combine their knowledge with that of other humans. And so I have an instinct that there's a lot of room at the top for AIs to get smarter. If I think of something like materials in the physical world, or like addressing conflicts between humans or something like that, I mean, it may be there's only some of these problems are not intractable but much harder, and it may be that there's only so well you can do at some of these things, right? Just like with speech recognition, there's only so clear I can hear your speech. So I think in some areas there may be ceilings in that are very close to what humans have done. In other areas, those ceilings may be very far away. And I think we'll only find out when we build these systems. It's very hard to know in advance. We can speculate, but we can't be sure.
And in some domains, the ceiling might have to do with human bureaucracies and things like this, as you write about.
Yes.
So humans fundamentally have to be part of the loop. That's the cause of the ceiling, not maybe the limits of the intelligence.
Yeah, I think in many cases, in theory, technology could change very fast. For example, all the things that we might invent with respect to biology. But remember, there's a clinical trial system that we have to go through to actually administer these things to humans. I think that's a mixture of things that are unnecessary and bureaucratic and things that kind of protect the integrity of society. And the whole challenge is that it's hard to tell. It's hard to tell what's going on. It's hard to tell which is which, right? My view is definitely, I think, in terms of drug development, my view is that we're too slow and we're too conservative. But certainly, if you get these things wrong, it's possible to risk people's lives by being too reckless. And so at least some of these human institutions are in fact protecting people. So it's all about finding the balance. I strongly suspect that balance is kind of more on the side of pushing to make things happen faster, but there is a balance.
If we do hit a limit, if we do hit a slowdown in the scaling laws, what do you think would be the reason? Is it compute limited, data limited? Is it something else? Idea limited?
So a few things. Now we're talking about hitting the limit before we get to the level of humans and the skill of humans. So I think one that's popular today, and I think, could be a limit that we run into. Like most of the limits, I would bet against it, but it's definitely possible, is we simply run out of data. There's only so much data on the internet, and there's issues with the quality of the data, right? You can get hundreds of trillions of words on the internet, but a lot of it is repetitive, or it's search engine optimization drivel, or maybe in the future it'll even be text generated by AIs itself. And so I think there are limits to what can be produced in this way. That said, we, and I would guess other companies, are working on ways to make data synthetic, where you can use the model to generate more data of the type that you have already, or even generate data from scratch. If you think about what was done with DeepMind's AlphaGo Zero, they managed to get a bot all the way from no ability to play Go whatsoever to above human level just by playing against itself. There was no example data from humans required in the AlphaGo Zero version of it. The other direction, of course, is these reasoning models that do chain of thought and stop to think, and reflect on their own thinking. In a way, that's another kind of synthetic data coupled with reinforcement learning. So my guess is with one of those methods, we'll get around the data limitation, or there may be other sources of data that are available. We could just observe that even if there's no problem with data, as we start to scale models up, they just stop getting better. It seemed to be a reliable observation that they've gotten better. That could just stop at some point for a reason we don't understand. The answer could be that we need to invent some new architecture. There have been problems in the past with, say, numerical stability of models, where it looked like things were leveling off, but actually, when we found the right unblocker, they didn't end up doing so. So perhaps there's some new optimization method or some new technique we need to unblock things. I've seen no evidence of that so far, but if things were to slow down, that perhaps could be one reason.
What about the limits of compute? Meaning the expensive nature of building bigger and bigger data centers.
So right now, I think most of the frontier model companies, I would guess, are operating in roughly $1 billion scale, plus or minus a factor of 3. Right, those are the models that exist now or are being trained now. I think next year we're going to go to a few billion, and then 2026, we may go to, above 10 billion, and probably by 2027, there are ambitions to build $100 billion clusters. And I think all of that actually will happen. There's a lot of determination to build the compute to do it within this country. And I would guess that it actually does happen. Now, if we get to 100 billion, that's still not enough compute, that's still not enough scale, then either we need even more scale, or we need to develop some way of doing it more efficiently, of shifting the curve. I think between all of these, one of the reasons I'm bullish about powerful AI happening so fast is just that if you extrapolate the next few points on the curve, we're very quickly getting towards human level ability, right? Some of the new models that we developed, some reasoning models that have come from other companies, they're starting to get to what I would call the PhD or professional level, right? If you look at their coding ability, the latest model we released, Sonnet 3.5, the new or updated version, it gets something like 50% on Swebench. And Swebench is an example of a bunch of professional real-world software engineering tasks. At the beginning of the year, I think the state of the art was 3 or 4%. So in 10 months, we've gone from 3% to 50% on this task. And I think in another year, we'll probably be at 90%. I mean, I don't know, but might even be less than that. We've seen similar things in graduate level math, physics, and biology from models like OpenAI's O1. If we just continue to extrapolate this, right, in terms of skill that we have, I think if we extrapolate the straight curve, within a few years, we will get to these models being, above the highest professional level in terms of humans. Now, will that curve continue? You've pointed to, and I've pointed to, a lot of reasons why, possible reasons why that might not happen. But if the extrapolation curve continues, that is the trajectory we're on.
So that was Dario Amodi. Got his take on the scaling hypothesis. At the end of the talk, he says maybe this is not going to be the way to go. Maybe the scaling hypothesis is kind of leveling off. Supporting data for that is OpenAI was predicting GPT-5 coming out in January 25. It's only recently come out in August in 2025, so they were delayed. They weren't happy with the results. We're not at AGI now in any way, but I want to take a look now at what Gary Marcus has to say, exposure to that. It's a very short snippet, but I think the point that he makes is at the end is important. It goes with my idea that the neural networks that we see are only a pale in comparison to what's going on in the human brain. Human brain has evolved over millennia. Our DNA has knowledge in it, knowledge for how to learn. Our visual system is ready to go. Our auditory system is ready to go. We understand the world. We begin to understand the world. The baby begins to understand the world very quickly because of the DNA, the knowledge that's built in. And I think the thing that set me off on creating this podcast was something that Gary Marcus says right at the end about how he feels that neuro-symbolic AI is the way we may be able to get to AGI by bringing knowledge in. And that essentially connects to my work on knowledge graphs and how to integrate them with large language models. So let's take a look at what Gary Marcus has to say.
So are you basically saying that what we have in AI today, this is it? Like this for generative AI?
For a while, I guess. I mean, look, I put out some predictions last year in March that people can look up that I had on Twitter. And those predictions included, I said there'd be no GPT-5 this year, or if it came out, it would be disappointing.
It's supposed to come in summer.
Well, this was last year. So I said
right.
In 2024, we won't see this. And that was a very contrarian prediction at that point, right? This was a few weeks after people had said, oh, I bet GPT-4 is going to drop off to the Super Bowl, like right after the Super Bowl. Won't that be amazing? So people really thought it was going to come last year if you go back and look at, what they said on Twitter, et cetera. And it didn't, and I correctly anticipated that it wouldn't. And I said we're going to have a kind of pile up where we're going to have a lot of similar models from a lot of companies. I think I said 7 to 10, which was sort of roughly right. And I said we were going to have no moat because everybody's doing the same thing. And the prices were going to go down. We'd have a price war. All of that stuff happened. Now, maybe we get to so-called GPT-5 level this year. Keeps getting pushed back. I don't know if we'll get much further than that without some kind of genuine innovation. And I think genuine innovation will come. But what I think is we're going down the wrong path. Jan LeCun used this notion of, we're on the exit ramp. Or how did he say it? Large language models are the off-ramp to AGI. They're not really the right path to AGI. And I agree with him. Or you could argue he agrees with me because I said it, for years before he did, but we won't go there. The broader notion is sometimes we make mistakes in science. I think one of the most interesting ones was people thought that genes were made of protein for a long time. So in the early 20th century, lots of people tried to figure out what protein is a gene made of. It turns out it's not made of a protein. It's made of a sticky acid that everybody now knows called DNA. So people spent 15 years or 20 years really looking at the wrong hypothesis. I think that giant black box LLMs are the wrong hypothesis. But science is self-correcting. In the end, people put another $300 billion into this and it doesn't get the results they want. They'll eventually do something different.
Right, but what you're forecasting is basically an enormous financial collapse because...
That's right. I don't think LLMs will disappear. I think they're useful. But the valuations don't make sense. I mean, I don't see OpenAI being worth $300 billion. And you have to remember that venture capitalists have to 10x to be happy or whatever. I don't see them... IPOing at $3 trillion. I just don't.
No, it's interesting because I almost see the OpenAI valuation as the one that makes the most sense because they have a consumer app. The place that I start to get, if what you're saying is correct, that we're not going to see any more, if we're seeing real diminishing results from scaling and this is basically where we are, then there's real worry for companies like NVIDIA, which has basically risen on the idea of scaling.
I mean, they're down a third this year.
Still
or something
2.5 trillion last
They're
time.
a genuinely good company. They have a wonderful ecosystem. They're worth a lot of money. I mean, I don't want to put an exact figure, but I'm not surprised that they fell, and I'm not surprised that they're still worth a lot.
No, but this is the thing. If we end up seeing the fact that this next iteration, the $10 billion that Sam is going to spend seemingly on the next set of GPUs, if that doesn't produce serious results,
That's going to hurt NVIDIA.
that will cause a crash in NVIDIA because so much of the company's demand is coming based off of this idea that scaling is going to work.
So they have multiple problems, both
Right.
OpenAI and NVIDIA. So one is, it does look to me like we're hitting diminishing returns. It does not look to me like this inference time compute trick is really a general solution. It doesn't look like hallucinations are going away. And it does look like everybody has the same magic formula. So everybody's basically doing the same thing. They're building bigger and bigger LLMs. And what happens when everybody's doing the same thing? You get a price war. So DeepSeek came out and OpenAI dropped its prices quite a bit.
Right.
And so because everybody, I mean, not literally everybody, but 10, 20 different companies all basically have the same idea, are trying the same thing, you have to have a price war. Nobody has a technical mode. OpenAI has a user mode. They have more users, and
That's the most valuable thing they have. Like for
That
them,
is the most valuable
API,
thing.
I would say the API is close to worthless. I don't know, worthless is the right word, but it's not worth very much.
It's not a unique product.
ChatGPT is the thing that
it's
really
the
has
name.
that.
It's the brand name that is most valuable.
I also think it's the best bot right now.
It might be. I mean, I think people go back and forth. Some people someday say it's Claude.
I've been on the Claude train for a long time.
And now you're on the
And
ChatGPT
I'm on
train?
ChatGPT. I think
What I think is going to happen is you're going to have leapfrog,
Right.
but the leaps aren't going to be as big as they were. So
Yeah.
4 was a huge leap. I mean, this is a different way of saying what I
Right.
said before. It was a huge leap over 3. Let's say, I can't even keep up with the naming scheme.
Okay.
GPT 4.1,
Right.
let's say, is better than Grok 3. Or Claude 3.7, let's just say, hypothetically. And so people run to this side of the room. And then, Claude, whatever, 3.8.1 or whatever, will be a little better. And then some people will run to that side of the room. But nobody's going to be able to charge that much money because the advances are going to be smaller. And people start to say, well, I use this one for coding and this one for brainstorming and whatever. But nobody anymore says, this is just like dominant. Like, GPT-4 was just dominant. When it came out, there was nothing as good as it. For anything, if you wanted this kind of system, you used it, right? I mean, that's my memory of it. I don't hear any of the Chat GPT or whatever, I can't even keep up with the names anymore, any of those products, any of the OpenAI products being referred to in the same kind of hushed tones, like they're just better. And Google's still in this race, and they may undercut on price. Meta's giving stuff away. People are building on it. DeepSeek, I hear, has something new that's going to, be better than ChatGPT. And, maybe it's true, maybe it's not. But we're... Some people take me as saying that AI is impossible. And that's not me, right? I actually love AI. I want it to work. I just want us to take a different approach, right? I want us to take a neuro-symbolic approach where we have some classical elements of classical AI, like explicit knowledge, formal reasoning, and so forth, that people like Hinton have kind of thumbed their nose at, but that, say, Demis Hassabis is used very effectively in AlphaFold. So we get into that if you want. If we get to AI, the question about whether I'm right or not depends on how we get there. So I've made some pretty particular guesses about it, and I have guessed that pure LLM will not get us there, pure large language model. So will I concede I'm wrong when we get to AI that actually works? Depends on how it works.
Okay. Yeah, and I think it's clear that, I don't know, we could watch this back in a couple of years.
If we get to pure LLMs, if
silly, but
another round
you're
of
right.
scaling, gets us to AGI by the criteria that I laid out, then I will have to concede that I was wrong.
So I hope you got something out of that. I hope you got a sense of the arguments going on about the scaling hypothesis. It's also very interesting to see the different players who are out there, and at the end, what Gary Marcus has to say about neuro-symbolic AI, looking at a slightly different way to approach large language models and AI. So I hope you enjoyed that.